Roof systems. In this segment, we'll discuss roof systems. Roof systems are like floor systems in many ways. However, where floor systems must be designed to support live and dead loads, a roof system must support not only the loads of the roof, but must be designed in a way that creates drainage. I would suggest reviewing our floor system segment, as roof framing can be similar. Roofs can come in many different forms and configurations and can be made of many different materials. Roof systems on residential structures are many times drastically different from those on commercial structures. Commercial roof systems can consist of steel, metal, concrete framing, as well as structural concrete planking, steel bar joist systems, and a multitude of other systems. In this segment, we will discuss wood-framed residential, light commercial, and multifamily roof systems only. Depending on the type of roof system a project calls for, roof framing may be almost identical to floor framing, such as a flat or low slope roof. The difference between a flat roof system and a floor system is not only does the roof need to support the load above, but ventilation and drainage need to be considered as well. Most roofs require some pitch for drainage. Pitch is the number of inches a roof slopes down per every 12 inches of run. Any roof system with pitch of less than 312 is considered a low slope roof. Most flat roof systems are not totally flat. Provisions are always made for drainage of water, snow, and ice. On a flat roof, pitch can be achieved in several different ways. Walls may be framed higher on one end to provide a slope for the roof. The roof may also be framed flat and then built up with tapered sleepers to provide pitch and drainage. Sleepers are typically 2x lumber, cross-ripped at an angle, and nailed on top of the roof joist to provide slope. In other cases, a roof may be framed completely flat and then pitch created by placing tapered insulation panels, usually made from polyisocyanurate, that are designed to provide slope and drainage on the roof itself. Some roofs are designed to hold water, such as a green roof. These are often found in urban areas where groundwater is a big concern. These roof systems are designed so that soil and vegetation can grow on the roof. The excess water drains through provisions built into the roof itself. As you can see, there are many factors to be considered even on a simple flat or low sloped roof. As we move on from flat or low slope roof systems to traditional pitched roof systems, the nomenclature for the components changes. We will discuss these components and how they are used. In these roof systems, the lower part of the roof is referred to as the eave, and the highest part, or peak, is the ridge. Pitched roofs can be designed in many different configurations. The most common configuration is a simple gable or A-frame in the shape of a triangle. The reason many roofs are in the shape of a triangle is because a triangle provides maximum strength and drainage. On a very basic gable roof, the bottom chord of the triangle, the ceiling joist, is typically level and spans from one side of the structure to the other, tying the exterior walls together. The two vertical sides, rafters, are at any angle needed to provide the desired look and pitch. When these three sides are joined together properly, the triangle becomes a very strong structure, and the downward force, snow, rain, and ice, from above would have to separate the sides from the bottom for the roof to fail. A properly designed roof will resist these forces. Most residential pitched roofs are variations of this. A roof pitched on more than two sides that comes together at an outside corner is a hip roof. The corner rafters are called hip rafters, and the shorter rafters that meet the hip rafter are called jack rafters. There are several ways for these types of roof designs to be framed. The most common method is that the ceiling joists are first attached to the top plates of the walls below. Ceiling joists can either span the entire distance of the structure or be split at load-bearing walls or beams if needed. Once the ceiling joists are installed, the rafters are cut to fit and placed beside the ceiling joist on the wall's top plates. The rafter tails are typically notched to sit on top of the wall and hang down below it. This notch is called a bird's mouth, and the overhang created at the eave is called the soffit. Ceiling joists not only provide the structural integrity to tie the entire roof structure together, but also provides the surface for the ceiling below. Ceiling joists are very similar to floor joists. If you've watched our floor system segment, all the basic materials we discussed there apply to ceiling joists. The difference between ceiling and floor joists are that in a typical roof system, ceiling joists only must span from bearing wall to support the load of the drywall or finished ceiling below and any attic storage space above, and provide space for insulation between the structure below and the roof system above. The rafters extend until they meet at the ridge. Typically, on a traditional framed roof system using ceiling joists, there is a ridge board that runs the entire length of the roof and is not structural, as it is only providing an attachment point where the rafters come together. Each rafter on each side of the roof is nailed to this ridge board, as well as to the walls below through the bird's mouth, and attached to the ceiling joist. When spanning longer lengths with rafters, a collar tie is usually added 1/3 of the distance from the ridge to provide additional strength. There is usually a finish board nailed to the ends of the rafters called the fascia. The fascia is typically a flat board that ties all the rafter tails together and provides a surface for the gutter to attach to. Sometimes, structures are designed so that there is no flat ceiling below and the rafters become the ceiling surface. This is referred to as a cathedral ceiling. When this is the case, there are no ceiling joists to provide that rigidity to tie the system together. There are a few methods that can be used to provide the structural soundness to frame this. In a true cathedral ceiling system, the ridge board becomes a beam with structural posts on either end. The ridge beam is designed to support the load of the roof. The rafters are then nailed or attached to the ridge beam, as well as to the top plates of the walls below, providing the same type of structural integrity as if ceiling joists were there. In this system, the ridge becomes the structural part of the roof that resists any forces from above. A variation of this is a tray or coffered ceiling system. The ceiling joists are eliminated on the wall plates and replaced by collar ties. In this system, the ceiling joists are now collar ties that tie the two rafters together and eliminate the chance of spread from any forces from natural causes or structures above. The ridge may or may not need to be structural depending on the design. Sometimes there is living space within the roof area, such as a bonus room or a finished attic. In these cases, the roof may be framed to provide structural support for the floor. Instead of ceiling joists sitting directly on top of the top plate of the walls below, floor joists will sit on the top plate, just like a conventional floor system. Subfloor will be nailed to this floor system to provide a surface for the bonus room or finished attic area. The rafters will be placed on a plate on top of the floor system. Hip roofs are designed to pitch in two directions, coming together at an outside corner. There is typically a rafter that runs from the corner of the building up to the ridge, which is called the hip rafter. The hip rafter is basically an angled ridge. There is not a lot of load on the hip rafter from above, as both roof systems pitched towards each other are squeezing the hip rafter and not producing a downward force. The rafters that tie into the hip rafter on either side that support the hip rafter are called the jack rafters. Valleys are created when two roofs come together on an inside corner. Valleys can be framed in several different ways. If you have a dormer that is purely aesthetic and has no usable space below that sits on top of a roof, that dormer can be overframed on top of the main roof framing. In this case, there are no additional loads placed on the structure of the roof other than the valley rafters that are supporting the dormer and whatever load might end up on top of that dormer. In a circumstance such as this, the main roof is typically framed first, and any roofs that are overframed on top of it are framed above and sit on top of a wide plate attached to the main roof called a valley plate. The valley plate is just there to provide support for the valley rafters of the overframed portions of the roof. Sometimes roofs come together on inside corners and provide living space below. In this case, a valley is considered a live valley and can't be overframed. This valley beam must be supported properly on both ends and must be sized to carry the load that it supports. The valley rafters from each section of the roof are attached to the valley beam, creating a usable space below. As you can see, there are virtually limitless combinations that can be used when designing pitched roofs for structures. Ceiling joists, rafters, ridges, hips, and valleys can be dimensional lumber or engineered products depending on the loads that they must carry. Ridges, hips, and valleys are typically deeper than the rafters they support. For example, if rafters are made from 2x10s, the ridges, hips, or valleys they fasten to are typically at least 2x12s, so that they provide a larger surface for the rafter, which is cut on a pitch to nail to. If the ridge, hip, or valley is load-bearing, then the size of the member is determined by the load it must support. Roof sheathing, like floor and wall sheathing, is typically sold in 4x8 sheets. The thickness and type will be determined by the roof design itself, the climate it's designed for, and the roofing materials that will be used on top of it. There are many products available when it comes to roof sheathing. Please refer to our previous segments where we discuss sheathing types. When using commodity plywood or OSB, the sheets must be spaced with plywood clips to provide room for expansion and extra support. Manufacturer specifications for fastening and installation must be followed to ensure product performance. Some roofing materials require ventilation that plywood would restrict, such as cedar shakes and shingles and metal roofing. Sometimes, when using these roofing materials, plywood is not used. A product, such as wood furring, called strip sheathing, can be used at specific on-center spacing to provide support to fasten the roofing materials to. Roof systems must be designed and engineered in a way that provides resistance to any wind forces based on the demographic area that the structure is in. Straps or hold-downs, called hurricane ties, are typically used to secure the rafter to the top plate of the wall that it rests on. There may be strapping required at the ridge to secure the rafters together around the ridge, or hangers may be needed at the ridge or at the eaves to provide support to fasten the rafters based on the uplift that might be placed on them. Like floor systems, roof systems can also be pre-manufactured off-site using trusses. It's very important to know the differences between a stick frame roof and a truss roof, as well as the materials needed for each. While a truss roof system replaces many of the items that are used to individually make up a stick-framed roof, such as rafters, ceiling joists, collar ties, and ridges, additional bracing must be used, and the additional labor and materials needed to make each truss must be considered when comparing to a stick-framed system. On a typical flat roof, trusses are very similar to floor trusses as discussed in our floor framing segment and can be designed to support the loads of a roof as well. Trusses can be manufactured and installed on-site to provide roof systems of just about any configuration or shape. Trusses may replace rafters, ceiling joists, collar ties, as well as beams and headers needed to support these items. In a typical roof truss system, there are 3 sections that make up each truss. There's a bottom chord, typically making up the part of the roof that would be the ceiling joist. There are top chords, typically making up the part of the truss that would be the rafters. And there are structural members called webs, which provide the support between the top and bottom chord. Ridges are not usually used in roof truss systems. However, bracing systems that are specifically designed for each roof design individually must be adhered to strictly to provide the support needed for roof trusses. While this segment did not cover every type of roof system and material that can be used on every type of structure, we have covered the most typical and provided the basic groundwork to understand roof systems and the components that make them up.